Morning on another present. Here I am Nandini D, working as an assistant professor in SNS College of Technology at the Department of Computer Science and Technology. Today we are going to see a topic of representation learning and latent variable with the help of DT framework. So first of all, the relationship between representation learning and latent variable. This representation learning mainly focuses on automatically learning meaningful features of hiding factors, which explains the observation data, discover the latent variable, compact meaningful representation, generalize the predict and generate the data. These are the relationships used. A problem statement has been defined. A real world such as image, text and speech contains important hidden patterns that are not directly observed. So we are going to see stage one by one. First is an empathy. Any real world data sets such as images, speech, text, which contains the complex patterns. Manually selecting useful features is difficult and time consumption. For example, in face recognition, the computer sees only the pixels but need to identify a person's face. We need a method that automatically learns meaningful future from data. This needs leads to representing learning and latent variable. So, and diagram being shown from text to image and image capturing, text to speech and image speech capturing. Next one is the define stage. In this define stage, a latent variable consists of observed, pre-observed variables which can be easily recognized. So for this, the challenges is to represent the complex data in a simpler and more meaningful way. Representation learning automatically extracts a useful feature from raw data. Latent variable are hidden factors that cannot be directly observed but explain the data. For example, handwritten recognition. Writing style is a latent variable that influences the appearance of the letters. These are the phases of an defined stage. Next is an ideate stage. We explore the different machine learning approaches. Traditional methods required manual feature extraction, while deep learning method learn feature automatically. Models as autoencoders, variable autoencoders, hidden Markov model, and Gaussian mixture models use latent variable to discover hidden patterns. These methods provides better accuracy and reduces the manual effort. A generative representation learning, self-supervised generative pre-training, multimodal generative models. These are all shown in the diagram. Next is an prototype model. In this prototype, AI safely features such as encoder, decoder, latent space has been available. This bias checker scans the AI output from bias to human languages. This transparency panel shows data source, confidence level resources. Private guardians filter the personal or sensitive information before output. Human review allows users or moderators to approve the rejection or edit the output. Ethical logic records the decision for accountability and auditing the purposes. In this prototype phase, we develop a representation learning model by feeding raw data into a neural networks. These neural learns a compact representation called a latent representation. This compressed information captures the important characteristics of the data while removing unnecessary details. The learning represents is then used for tasking such as classification, clustering, or prediction. And the phase is in testing phase. In this testing phase, encoder, decoder, we also have some reconstruction accuracy test, latent space quality test, private leakage test, bias evaluation test, generalization test, noise and perturbation test, end-to-end generation test, and performance and scalability tests have been used here. In this, finally, we test whether the learned representation improved performance. We measure accuracy, precision, or reconstruction error depending on the task. If the results are not satisfied, we modify the model, collect more data, or tune the latent variable. This identify process helps create a more accurate and effective model. In these models, these accurate tests have been used to compare the original input versus reconstructed output, check the clustering, smooth interpretation, ensures the sensitive attributes are not recoverable, validate latent representation across the different groups, test on unseen images or text or speeches, add noise to input or latent vectors, sample from latent spaces and verify the meaningful data generations, measure the latency, memory usage, and throughput during the encoding stages. These representation learning automatically learns useful features from raw data, while latent variable represent the hidden factor that explains the data. So activity and mind map is done. Thank you so much for the video.